Thank you very much, Fabrizio, for the kind introduction. Thank you to all of you for still being around after 3 days of interesting discussions. I think it's a good transition from some of the questions that were raised at the end of the previous presentation. I'm happy to be able to present to you some very recent results from a test program that we ran on a plug-in hybrid vehicle that was relying on the GDI engine for the internal combustion part, and that we tested under RDE conditions. So for those of you who may not know AECC, we are the Brussels-based association representing European emissions control manufacturers. Our members are represented by their logo on that slide. And our members are developing and manufacturing exhaust emission control technologies mainly for original equipment, but also for retrofit and aftermarket, for cars, commercial vehicles, motorcycles, non-road mobile machinery. So we are covering all mobile sources, emissions from all mobile sources. So the content of my presentation today, I will be quick on the context because I think we've heard quite some insight on the RDE legislation and the European emissions legislation developments. We'll review the program setup that we had, and then we'll go through the real driving emissions results with a particular focus on particulate number, where we use the vehicle as it is on the market without a GPF, and with a GPF retrofitted. I will also share some results on NOx emissions from that vehicle and on shortly on CO2. And then I will mention some brief outlook. So the context is obviously the development of the RDE legislation, which aims at closing the emissions gap that exists between laboratory and real world. I think the key driver from the beginning of RDE development has been diesel NOx, as is kind of represented on the left part of the slide with some ICCT graphics, where the NOx emissions from diesel cars have been exceeding the European standards and the limits for some years. I would be happy if ICCT was updating their slide with some of the emission analytics results for 2016, 2017, where we have a little bit less black clouds. But the purpose of my talk today would be more related on the right side of the chart, and the fact that particulate number emissions also have to be controlled in real world. And we all know that since 2011 and the introduction of Euro 5 to all new cars, then diesel cars are equipped with very efficient diesel particulate filter. I have, in that conference, presented 2 years ago some on-road data from such a DPF-equipped diesel car, where we see that the emission limits is largely above the real-world emissions of such a car. But the fact that with some of the direct injection gasoline cars, control of particulate number emissions is manageable from an engine perspective on regulatory test cycle, NEDC or WLTP. But when you broaden the test conditions and the operating points of the engine that have to be controlled, then it becomes much more difficult to control particulate number emissions from the engine measures only. And the use of GPF is seen as the most likely technical solution for that. This is a recent public presentation from FEV of last month. So short summary of the RDE legislation, just to the key elements that relate to my presentation. The NOx to exceed limit, that is the emissions in milligrams per kilometer that cannot be exceeded on the road, and they correspond to the Euro 6 limit times the conformity factor. CF is defined for NOx and for PN, and it applies to all cars to which a limit is defined. So that means we were talking about MPI, for which there is no PN standard in Euro 6, so there is no RDE requirement for particulate emissions for these cars. But for GDI and plug-in or hybrid vehicle that use a GDI engine, then there is a NOx and a PN conformity factor. There is a staggered introduction of the standard to new types and all new vehicles, but I will not spend too much time on that. That's been already clearly described this morning. What needs to be well understood is that there are boundary conditions that are defined and that make sure that the test that is being evaluated is not biased, basically, so not too weak, not too stringent, but representative of a normal driving. So there are some specifications to design your route. There are also boundaries on the ambient conditions, meaning the temperature, the altitude gain, and some boundaries on driving dynamics. So to have a valid test, according to the RDE procedure, you have to meet all these requirements. The RDE legislation we've heard is still being finalized with the 4th legislative package under development, and that includes the how you would post-process or analyze emissions, RDE emissions from plug-in hybrid vehicles. So what I will present today are raw emission data without any post-processing. So our program, test program had as an objective to evaluate the behavior or the real-world behavior of a car, a PHEV car that is supposed to be a representative of the market. And we selected for that purpose a PHEV car in the C segment, obviously with a GDI engine in the car, in the class of around 1.5 liter. So this car was a Euro 6B car, so not RDE compliant, but still very quite recent. The car that we rented was actually about 10,000 kilometers, had driven 10,000 kilometers. This particular model has 4 driving modes that can be selected by the driver. So the electric mode, which makes the highest use possible of the electric motor, a hybrid mode that we'll describe a little bit later on. Interestingly, a charging mode, so that means you can recharge your battery using your internal combustion engine, which is not the most efficient way, but it's still a possibility on that car. And a sports mode, which improves the interaction between the internal combustion engine and the engine motor to enhance drivability and the dynamics of the car. That particular car had an official electric range of 50 kilometers. On some of the emissions results, I will compare our measurements to a previous test program that we ran last year, and that was the subject of a recent AECC paper. You have the reference here, where we did the same kind of measurements, but on a GDI car. So I will compare the impact of electrification on a car of the similar segment. So our tests were run at Ricardo in the UK, and we all run on market fuel, E5 market fuel. We used the Horiba PEMS OBS1 PEMS sensor for CO2, NOx and PN. And as I mentioned earlier, I will show you the raw emissions data for the urban driving part and for the total RDE trip. So the urban part is actually the cumulative emissions for all driving points below 60 kilometers an hour. So it means in the rural area, so you drive urban, rural and motorway, but if you have in the rural part some times where the car is below 60 kilometers, then this accounts for urban driving. So we drew test metrics where we wanted to evaluate the 4 different driving modes that are offered on that car. And we also evaluated the impact of the initial battery charging. So we varied the state of charge of the battery at the start of the testing. And for time and budget reasons, we only repeated 2 tests with, where the GPF was fitted in the exhaust line. So just a short overview of our trip. So it's in the UK at Ricardo, close to the seaside. So you see the urban part. Is it this one? So the urban part in the city, and then you go in the rural area, and then finish on the motorway. Here you see the speed. So that's the urban part. Then you go on the in the rural part, and then you finish on the highway. So the test metrics that we measured, so a combination of modes and state of charge of the battery. So first, if we look at the electric mode, so you see here on this chart the battery state of charge evolution during the PEMS trip on the road. So if you start from a fully charged battery, then you see that you're in a charge depleting mode until you reach the minimum level of battery, and then the internal combustion kicks in. It happens during the rural driving part. But if you start with a lower, if somebody hasn't recharged his battery overnight, then it starts with we tested here 55% initial state of charge. You will keep decrease or run in charge depleting mode, and then the internal combustion engine will maintain the battery at the low, or will kick in, and the battery will remain at the low level. And there was even on one test where we were already almost at the minimum state of charge, so it's basically a charge sustaining test that was run. Then in blue we have the hybrid modes. So basically this is a mode where the state of charge is maintained, so some sort of a charge sustaining mode, even though it's not the exact definition in WLTP, but that's so if you start from a certain state of charge, then the battery remains stable at the same level. The charging mode that I mentioned earlier, so we started with the battery was flat, and then you can recharge your battery while you are driving on the ICE. And finally, the last modes are the sport mode. So we run it once with the battery fully charged. So that's also some sort of a charge sustaining mode, and with a lower state of charge. And then you have some charging that happens. In terms of RD measurement, it's just an overview to check that all our testing were meeting the validation criteria. So here you see the ambient conditions, so the ambient temperature and the altitude of your test. And we have 2 boxes. So this is the moderate boundary conditions, in which the conformity factor applies directly. And this is in a dash line, within the dash line, the extended boundary conditions, in which you multiply your conformity factor by 1.6. So there is some further allowance for these extended boundary conditions. But all our testing were within this blue box, so all within the moderate boundary conditions, with a reasonable range of temperature, but obviously a relatively low altitude because we were close to the seashore. We also checked the dynamicity of our tests according to the legislative requirement. So you have to calculate for each urban, rural, and motorway phase your the speed times positive acceleration, and you take the 95th percentile of that, and you have to be below that red line. Basically, if you're above, that means you're driving too aggressive, and that's not representative of normal driving. If you're really low, then the test is valid, but it's not in the worst condition, let's say. So there is still some room to make it more aggressive. And on the opposite, you also have the relative positive acceleration measurement for each phase. and that checks that you shouldn't be below that limit, otherwise it means the driving is too much of a grandma style and too lenient, not representative either. So you see that in all our testing, we were within the validation area, with some of the testing that were already quite close to the upper boundary limit. There is also some, as I mentioned, some validation of the altitude, the accumulation of the altitude. And even if the altitude that we measured was not that high, we see that in the cumulative value is in the range of 750 meter per 1,000 kilometer. So we are below the limit, but not too low. So now if I come to the emission measurements results. So we see that on this chart, this is for the urban particulate number emissions only. And we see the different modes that we tested together with the initial state of charge of the battery. So we see, I mean, yeah, the green bar is absent. This is the electric mode with the battery charged, fully charged. And we've seen that we are depleting the battery throughout the entire urban part. So obviously that results in zero tailpipe emission during the urban driving, the urban driving. For all the modes, we have some urban emissions, and we see that in the worst case, with the charging mode, we even exceed the conformity or the not to exceed limit with a conformity factor of 1.5. This is because of the high power demand on the ICE. If we look at all the other results, and so these are the different modes with this PHEV car, and we compare with our previous GDI car that we had tested last year, and we see that this GDI without a GPF was here in the black bar, and when we had fitted the GPF, then we were here. And you see that all the PHEV results, except for this very high number, falls in between these two values. Now, if we go to the complete RD tests, so the total 80-something kilometer of tests on the road, then we see that in that case we are all below the not to exceed limit, just borderline for the higher tests, and that in that case with the electric mode, 100% battery charge at the beginning, where we had no or zero tailpipe emission in urban, then we see that for the total trip, then we are very much equivalent to any other test, including the not much lower than the GDI car without a GPF. So this is, we'll see on the next slide, the reason for this very high number, and that's on this chart. So the PN emissions in total are very much linked to the cold start of the internal combustion on the car, which I repeat, is not RD compliant, so there is probably some improvement that can be made from the engine management, but that's how the car performs actually on the market. And we see that, for example, in the charging mode, where the IC starts immediately and is very highly demanded because it has not only to move the car, but also to charge the battery, then we see that we have an initial spike of PN that is really high. And we see that for the electric mode fully charged battery, then we have the engine, the internal combustion engine kicking in here, and that has an extremely high spike. There is a high power demand, and at that particular moment in time, and the whole engine and exhaust line is cold, and so that results in this very high level. In the other electric modes, we also see that big impact when the internal combustion engine starts. And we see that overall, I mean, if we look at all these all the values from this PHEV, they all fall in a relatively small range. This is compared, for example, to the GDI car that we had tested. So this was without a GPF here. And once the GPF was fitted, then the emissions were there. Then we retrofitted the second three-way catalyst, because this car has a close-coupled three-way catalyst and an underfloor one. So we replaced the underfloor one with a coated GPF. And if we look at the particulate number emissions, so now we have the total RDE on top and the urban RDE below. And we repeated two tests, so the two tests in electric mode, so with a fully charged battery and with a 25% battery charge at the start. And we see that the high spikes, the high peaks of emissions that we have observed when the internal combustion kicked in are well controlled by the GPF, where we see that the emissions with the GPF are much lower than the not to exceed limit, and even lower than the GDI car fitted with the GPF. And that is observed for the total RDE and also for the urban RDE in the case where we had some emissions in the urban part. Now, if we move to the NOx emissions, so first on the total trip, the total RDE trip, and then we see first that whatever combination of mode and state of charge of the battery, we were always largely below the not to exceed limit. And the comparison to the GDI car, I mean, they are spread around this value. In some conditions, you are slightly better, in some conditions, slightly worse, but that's in the same ballpark figure. We see that also when you have your battery is properly charged and you start with a full battery, then you consistently get the lowest NOx emissions for your trip. So that's for the total trip. And if we focus on the urban part, so all the values, all the emissions that are emitted when the car runs at a speed less than 60 km per hour, then we see that again we are meeting the not to exceed limit for all test conditions for NOx. In the particular case of electric mode 100%, there is a small figure because of some vehicle speed that are below 60 km an hour that are outside or that are in the rural part, but geographically, if you concentrate on the urban part, then there is a potential for zero NOx emission in the urban part. And again, the comparison to the GDI vehicle, the GDI results falls in the middle of the various performance observed with the car. Again, with the properly charged battery, that's when you get the lowest NOx emissions. But that's something that remains to be seen, whether a customer would consistently recharge the battery as expected. An interesting value on this one, I mean, even if we are below the NOx, the NTE for NOx, we see that in the electric mode, but with only a partially charged battery, then that's when we get the highest NOx emissions. And that relates again. You see here the 1 second data throughout the RDE trip. And we see that when the internal engine kicks in, when the battery reaches its lowest level, then you get really quite important NOx peak that needs to be addressed by the three-way catalyst. So there is some impact on the from the cold start with the charge mode also with that is very demanding from the beginning, and also with the electric modes that fall in the middle. Final set of data on the CO2 emissions that were measured with that car. In that case, more than for pollutant emission, we see more straightforward impact of the level of battery charging and the modes that are used on the vehicle. So the lowest, so here it's for urban RDE and here for the total RDE. And we see that the lowest CO2 measurement is achieved with in the electric mode with a fully charged battery, and it decreases with the level of the battery. So the less your battery is charged at the beginning, the more CO2 you will get, and you get a very high CO2 value of almost 300 grams per kilometer when you are operating your car in charge mode. That also comes with the measurement of the electric range that was achieved with the car. So the official value was 50 kilometers on the COC of the vehicle. What we measured with this car, which was relatively new, was about 35 kilometers. So to conclude, this test program was for us the opportunity to test one somehow representative Euro 6B PHEV in the C segment. Again, not showing any data post-processing, as this is still under review for the legislative package 4 of RDE. Observations on PN and NOx real driving emissions are that there is zero emission capability in urban environment, and that is ensured when the electric mode is used and the battery has been fully charged. For NOx results, then in all conditions we were meeting the not to exceed limit, so which was a very positive outcome. And on the particular vehicle that we tested, this plug-in hybrid, we see that the timing of the internal combustion engine cold start during the RDE trip has a very important impact on NOx and PN emissions. We observed high spikes when the IC engine started, but these spikes are well controlled by an efficient gasoline particulate filter. Well-integrated exhaust after treatment is required to efficiently control emissions under all these RDE driving conditions, and that will include thermal management most likely. So this is a first report on the results of this test program, but we have investigated more on this vehicle, and we will publish that in the coming month, but this is quite recent. So what we have done is that you remember this V times A positive chart where you test the dynamicity of your test. Ricardo has developed with our previous test program a methodology to you put the vehicle back on the chassis dyno, and you increase the load and you modify the accelerations of your trip, and that allows to be at the worst case just on the border of V times A positive. So that's done in a climatic chamber, sorry, and so that allows also to combine this aggressive dynamicity with a low ambient temperature, and that's expected to be representative of a worst case condition, which is what is of interest for RDE, because it's not to exceed in all conditions and not averaging of emissions. We have also measured sub 23 nanometer particles to evaluate the impact of the legislation that is currently measuring the number of particles with a cutoff size in the system of 23 nanometer according to the PMP. So there are some discussions whether this limit is still appropriate for cars other than diesels, in particular GDIs. So we have measured the share of these ultra-fine particles, and I can already say that we are confirming the results that were shown previously by Corning, that the GPF really well control also these particulates. So that's not of an issue with once a GPF is fitted. When there is no GPF, then the question remains more open. And with that said, I think the light is turning orange, so it's time for me to thank you and maybe answer any question you may have. Thank you.
Thank you very much. Thank you very much, Cécile. Cécile, are there any questions for Cécile?
I think everybody's eager to go back home.
No. One question, and it's more like a comment based on what I could see. My understanding is that it's much less straightforward to validate, to certify a hybrid under RD and following a WLTP test, because you need to you have another variable that is the share of the time using the battery, the share using the gasoline engine.
Yeah, there are very different modes of usage of the car, and you don't know how the customer will use his vehicle. So, from our perspective, what is important is that any kind of combination of modes and initial stage of charge of battery have to meet the not to exceed emissions. So it's so broad that you cannot test that for type approval, obviously, but that at least during market surveillance, the third-party testing can choose to evaluate any combination of modes.
Okay, great, makes sense. Any questions? There's one. Just.
Thank you. I have a very, very simple one. You always showed the reference of the conventional vehicle. You didn't show it in the CO2 data. Can you comment if I was not impressed by the CO2 data. How does it compare to your reference vehicle?
I understand that the GDI reference vehicle was of a different power, so we decided not to compare CO2 because it wouldn't be really fair comparison. But I can check offline and give that information to you. The CO2 value of the GDIs are in the AECC paper anyway, so yeah. But the range of CO2 emissions from the plug-in hybrid vehicle are not, I mean, it can be quite good when it's properly used, but there are a number of other possible combinations that are not really providing any great improvement in terms of CO2 emissions.
Great. Any other questions for Cécile? Okay, so thank you very much.
Thank you.
Thanks for joining.